All right, this is section 10-1, areas of parallelograms and triangles. All right, so this diagram below shows the different types of parallelograms. So we have a parallelogram, okay? And if you remember, we had a Venn diagram problem like this earlier, okay? And from parallelograms, we also have rhombuses, squares, and rectangles. And remember, rhombuses can also be squares, and rectangles can also be squares. So underline the correct word to complete the statements. All parallelograms are quadrilaterals. All parallelograms have opposite sides parallel. Some parallelograms are rectangles. Okay. So definition, area is the number of square units needed to cover a given surface. You can find the area of a parallelogram or a triangle when you know the length of its base and its height. So let's try a couple. So let's look at number 4. So here's a rectangle, and to find the area, we just count the number of square units. So we have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and there comes out to be 18 square units. All right, now let's take a look at number 5. So if I count number 5s, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18 when I add those halves together. And in number 6, I get 1, 2, 3, and then 1, 2, 3 halves, so I end up getting 4.5 square units. All right, so theorem 10.1 and 10.2, the area of a rectangle and a parallelogram. So the first formula we get in chapter 10 is the area of a rectangle. We need to know that. The area of a rectangle is equal to the base times the height. And by definition, the base and the height are always perpendicular to one another. So the same thing goes along with the parallelogram. The area is the base times the height. Now the hiccup here is, remember, the base and the height have to be perpendicular. So let's explain how we find the area of parallelogram and find the area of rectangle are alike. For each figure, okay, you find the product of the base and its corresponding height. Okay, so let's try problem number 1. So what is the area of a parallelogram with base length 12 and height 9? So problem 8, let's label the parallelogram. So we know the base is 12 meters, let's label that. And we know the height is 9 meters, let's label that. All right, let's find the area. Substitute into the formula. So the area equals 12 times 9. Multiply 12 times 9, we get 108. So the area of the parallelogram is 108 meters squared. All right. Now, what if I know a parallelogram has sides 15 and 18, and the height corresponding to the 15 centimeter base is 9 centimeters? What is the height corresponding to an 18 centimeter base? So number 11, let's label the following pieces of information. All right, so we know that the base here is 15 centimeters. We know this is 18. We know this is the height corresponding to that base of 15, so that's 9 centimeters. We don't know what this is, so let's call this H. So let's find the area of this entire figure first. So the area is base times the height, which is going to equal 15 times 9, which is going to equal 135. So the area of the parallelogram is 135. Now, the interesting thing is this same area is true no matter which base and height I use. So I'm going to switch those up. So I know that the area is 135, but now I'm going to use the base of 18 times the h that I don't know. I'm going to divide both sides by 18, and I'm going to get 7.5 as the height corresponding to the 18 centimeter base. All right. 10-3, area of a triangle. So the area of a triangle is half the product of a base and the corresponding height, or the formula A equals 1/2 base times the height. So for a triangle, find half the product of the base and height. For a rectangle, find the product of the base and the height. Okay. So let's try problem number 3. What is the area of this triangle to the right? To circle the formula I would use, and I would use this formula here. All right, let's convert the length of the base of the hypotenuse to inches. So we notice we need to have the same lengths. So the base, 1 foot equals 12 inches. The hypotenuse, 1 foot, 1 inch equals 13 inches. So find the area. Area equals 1/2 base times the height, which is 1/2 the base, which is going to be 12, times the height, which is going to be 5. So that equals 1/2 times 60, which equals 30. So the area of the triangle is 30 inches squared. Okay. So what if I have an irregular figure? So suppose the base lengths of the square of the triangle and the figure are doubled to 12 inches, but the height of the polygon remains the same. What is the area of the figure affected? All right, so the area of the original irregular figure is 6 times 6 plus 1/2, 6 times 8. So this is the area of the square in the bottom plus the area of the rectangle at the top, of the triangle at the top. So we get 36 plus 24, which equals 60. Now I'm going to double the area, okay, but the height stay the same. So I get 2 times 36 plus 2 times 24. So I'm going to get 2 times 36 plus 24. So that's going to be 2 times 60, which is going to give me 120. So the area is doubled. Okay. So parallelogram ABCD is divided into 2 triangles along the diagonal AC. If you know the area of the parallelogram, how would you find the area of triangle ABC? Well, since AC is the diagonal of parallelogram ABCD, triangle ABC is congruent to triangle CDA. Is that true? Yes. So the area of triangle ABC is greater than the triangle CDA? That's false. The area is half the parallelogram. That's true. So all I need to do is divide the area of the parallelogram by 2. And that's the end of this section.